Hello everybody, welcome into another lesson. So today we are going to talk about perfect square binomials. Here we have the quantity of y minus 7 times y plus 7. So let's use our FOIL method. We'll take y times y, which would be y to the second, plus 7 times y, which would be 7y, minus 7 times y, which would be minus 7y, then negative 7 times positive 7, that'd be negative 49. Which when you simplify this, you'll get y squared. The 7y minus 7y, those go away. You just get y squared minus 49. Alright, I'm going to do a couple here with the classic FOIL method to illustrate a pattern, because you're about to learn a shortcut today. Alright, we got m plus 8 times m minus 8. Well, do our FOIL method, m times m, that'd be m squared, minus 8m, that'd be, well, minus 8m, plus, and then plus 8 times m, that'd be plus 8m, then 8 times negative 8, that'd be negative 64. Well, simplify this, you would get m squared, negative 8m plus 8m 0, you just get m squared minus 64. These are what's called a perfect square binomial, because both terms, the m squared and 64, are both perfect squares. You get m squared you get m, 64 you get plus or minus 8. So, if you're noticing the pattern here by now, if you have the same variable on each term of the multiplication and the same constant, 1 plus, 1 minus, you end up getting a perfect square binomial. The middle terms will always cancel out. So there is a shortcut. There is definitely a shortcut for this, so you don't have to even do FOIL. Let's say you have 4 plus x times 4 minus x, okay? Well, we notice we got the same constants, the same variables. What you're going to do is you're going to take 4 times 4, that'd be 16, of course. If you did negative 4x plus the 4x, that's always going to cancel out. Then you just have minus x squared. So whenever you have the same constant and the same variable, 1 plus, 1 minus, the middle terms will always cancel out. You'll end up getting the first term squared minus the second term squared. That's a shortcut we can use to save you the trouble of using the FOIL method. You would end up getting 16 minus x squared, and I got more of this. You end up getting a perfect square binomial, is what it's called. Alright, this one. We got 9 minus w times 9 plus w. Okay? Well, we got the same constants of 9 and the same variable w, one's plus, one's minus. So 9 times 9, that's 81. We can skip the middle steps. Negative w times positive w, that'd be minus w squared. So you would get 81 minus w squared. That saves you the trouble of foiling, but it only works again if you have the same constant and the same variable, 1 plus, 1 minus. That's the only way it's going to work. Alright. We have 5y minus 2 times the quantity of 5y plus 2. Well, what we're going to do is we're going to take 5y times 5y because we have the same variables and the same constants, 1 plus 1 minus. It meets the criteria of a perfect square binomial. You'll take 5y times 5y, which would give you 25y squared. Then you have negative 2 times positive 2, that'd be minus 4. So the answer you should get for this would be 25y squared minus 4. See how much trouble that saves you from foiling and skipping those intermediate steps? It's going to make your life a lot easier. Alright, let's see. We got 8x minus 11 times the quantity of 8x plus 11. Well, what we're going to do, take our 8x times 8x, that would give you 64x squared. Then we got negative 11 times positive 11, that'd be negative 121. So the answer you should get is 64x squared minus 121. Now, had we had different constants for the variables and then different coefficients for the variables and different constants, we would have had to do the full FOIL method. But when you have the same constants on the variables and the same coefficients on the variables and the same constants, 1 plus 1 minus, you can just do the shortcut method. That's the only time it works. Alright, let's see. We got the quantity of 3x plus 2y times the quantity of 3x minus 2y. Same constants and variables, 1 plus 1 minus, we can use the shortcut. So what we have to do is take the 3x times 3x, that'll give you 9x squared. Then we have positive 2y times negative 2y, that'd be negative 4y squared. So the answer you should get for this would be 9x squared minus 4y squared. See, you can use FOIL, that's fine, that's perfectly acceptable, but this method's saving you a lot of steps. It's saving you a lot of headache. And I don't know about you, I'm all about saving extra steps if I can help it. Alright, let's see. We got x squared minus 9y times x squared plus 9y. Same variables and then plus or minus. So we can use the shortcut method. X squared times x squared, that's x to the fourth. Now we got negative 9y times positive 9y, that gives you negative 81y to the second. So you should get x to the fourth minus 81y to the second. So see, that's going to save you a lot of grief. Alright, I'm just going to do a few more examples here. This will be a relatively short lesson. So we have 2r squared plus 7s squared times the quantity of 2r squared minus 7s squared. Well, we have, again, these can be perfect square binomials. We have the same powers and variables and then 1 plus or 1 minus for the second term on each, so we can use the shortcut. So 2r squared times 2r squared, that'd be 4r to the fourth. Then we have 7s squared times negative 7s squared. That'd be minus 49 s to the fourth. So what we should get here is 4r to the fourth minus 49s to the fourth. So much better than foiling, isn't it? So much better than doing all the steps out. Alright, 2 more examples, then we're done. We have AB minus C squared times the quantity of AB plus C squared. Well, what we do now, since we have the same variables for the first term and then we have a plus or minus C squared, we can use the shortcut. So AB times AB, that'd be A to the second, B to the second. Then negative C squared times positive C squared, that'd be negative C to the fourth. So what you should get for this is A squared B squared minus C to the fourth. One more example, then we're done. We have the quantity of xy plus 3z times the quantity of xy minus 3z. Well, we have the xy's for each of the first terms on each of the multiples. Then we have plus 3z minus 3z. We can use the shortcut. So xy times xy, that's x squared y squared. Then plus 3z times negative 3z, that'd be minus 9z squared. So the answer you should get for this would be x squared y squared minus 9z squared. So takeaway is, if you have the same variables on the first term, then plus or minus the identical term on the second term, you can do a perfect square binomial. Perfect square binomial is both the first term and second term have perfect squares. They have a perfect square root. So it saves you the shortcut of foiling and all that trouble. It's so much easier. So next lesson we will do factoring perfect square binomials. I'll show you how to do that, which actually isn't that bad either. So I hope everyone has a good day. Take care.